With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, welcome to Doubtnut. In this question given, block of mass m2 is in equilibrium and at rest. The mass m1 is moving with the velocity u vertically downward, collides with m2 and stick to it. Then find the energy of the oscillation. Okay, then actually this is the mass m2 and this one is m1 and moving with the velocity u1 and the spring having the spring constant is k, and we have to find the value of the energy of the oscillation. Okay, that means the energy is actually equal to the kinetic energy plus potential energy. Okay, potential energy and kinetic energy of the system, and this is equal to half mv square plus potential energy in spring mass system, and this is equal to half into k into x square. Okay, then firstly we have to find the value of the final velocity. Okay, then applying the conservation of linear momentum. Okay, and this is equal to m1 into u plus m2 into 0, and this is equal to m1 plus m2 into u. Okay, sorry, v. Okay, final velocity for the combined system m1 plus m2 is v. That means the value of v, and this is equal to m1 upon m2 plus m1 into u. Okay, this is the value of velocity, final velocity when the m1 is stick to m2. Then kinetic energy of the system, and this is equal to kinetic energy, that means half into m, and m is the total mass m1 plus m2, m1 plus m2 into v square, that means m1 square u square upon m1 plus m2 to the whole square. Okay, then m1 plus m2 is cancelled out with one m1 plus m2, that means kinetic energy, and this is equal to kinetic energy, and this is equal to half into m1 square u square upon m1 plus m2. Okay, this is the value for kinetic energy of the system m1 plus m2. Okay, let us consider the initial length is L. Okay, and m2, due to the m2 weight is acting in downward direction m2 into g, and spring force is acting in opposite direction, and let us consider this is k into x1 force is acting. Okay, then for equilibrium m2 into g, and this is equal to k into x1, that means the value of x1 is equal to m2 by k into g. Okay, when the m1 is stick to m2, then combined system is looks like this. Okay, and let us consider this is combined mass m1 plus m2. Okay, and let us consider extension is x2 and k is the spring constant. Then for equilibrium this is equal to m1 plus m2 into g, and this is equal to k into x2, that means x2 is equal to m1 plus m2 upon k into g. Okay, this is the extension. When the mass m1 is stick to it, then definitely the value of x2 is greater than x1. Okay, then total elongation, and this is equal to x2 minus x1. Okay, and this is equal to m1 plus m2 by k into g minus m2 into g by k, and when we solve then we get this is equal to m1 into g by k. Okay, then energy of the spring mass, and this is equal to half of k into x, and this x is actually x2 minus x1, and this is equal to m1 g by k to the whole square. Okay, this is the value for the potential energy. Then energy of the oscillation, and this is equal to kinetic energy plus potential energy, and kinetic energy is half into m1 square u square upon m1 plus m2 plus, and the potential energy is half of K into m1 square G square upon K square. Okay, this is the value for total energy of the oscillation. E is equal to half of m1 square U square upon m1 plus m2 plus half of K into m1 square G square upon K square. And this is the right answer of this question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.